Hello everyone. In this video we are going to look at parametric design in Fusion 360. So let's say here I have this bolt and I use some parameters in it, like the length of the shaft and then the major diameter and pitch, although I'll show you you cannot necessarily directly use that pitch in the design because it gives you a drop down menu, but you see that I have lots of different formulas based on D and L, okay? Especially D, which defines most of the things for designing a bolt. And so here the goal is to define some user parameters, and then model parameters are basically your equations. So how can you do that in Fusion 360 if you want to create a parametric object like this bolt or not, or washer or anything? How would you do that? So let's say, for instance, we want to create this bolt, okay? If I want to do it from scratch again, so I click here, go to a new design, and the first thing I do is I create the parameters, right? So if you go under modify and go here, it says change parameters. This is where you can create your user parameters. You click on this plus, and let's say D, and the D is 10 mils. You can even add a comment. You say, for instance, this is your major diameter, right? And you create that. There we go. And then you can add another one. Then say P, and P is 1.5 mil, and this is like the pitch. And finally, you can add one more, L, and L is, let's say, 40 mils, and this is the shaft length, right? Okay, so I got these three parameters. They are ready. And now I can go ahead and start creating the parts. So for instance, I go on the XY plane, right? And then I start a sketch, and then I draw the circle, which is for the shaft, and I create it. Now, when I want to give it dimension with D, instead of typing a number here, I just say D. You see, and it brings that D, and if I enter, done. That's 10 mil, and you see there is FX next to the 5, which means this number comes from a formula, comes from a parameter in this case. So there we go, I got that, and now I'm going to extrude this one. And for the extrusion length, instead of typing a fixed number here, like what you can see, I type in what? I type in L, and immediately brings L, and I OK that, and there we go. That's the shaft. Then on this top, I'm going to create the hex head. So I go with the sketch, and then under sketch, I go with the polygon, and then this one, click at the center, and of course I need 6. So here we go, we draw that. And then we force this one to be horizontal like this. And then we use the D tool, and corner to corner should be 2D. So this one should be equal to D and then times 2. You see here I'm using an equation. There we go. Get out, and then the extrusion for this should be 0.75 times D. So I say D and then times 0.75 or 7.5 mil. There we go, that's the head. Now the head has this cut revolve on the top side of it. For that, I need to go to this front plane, create a sketch, and then for that sketch, which is a right triangle, so here I use the line tool, and I draw a right triangle. This angle here has to be 30 degrees between this line and this one. And then the length of this side should be equal to D times 0.134, like that. Enter. Now here you see that the profile is good, but remember this edge and this one should be coincident, right? And here I try to grab that line and then this one, and you see it does not necessarily allow me to do that and then force them to be collinear, right? So if I can pick collinear, and you see here I'm picking that, and then let's see if it allows me. There we go, seems like it did. So now it should be good, although it's not perfectly fully defined. Why not? Because this top edge is still dangling. This top edge still should be allowed to move. So again, I have to pick this one and then go to collinear, then see if it allows me to pick this. There we go. That's now the perfect profile. I got that, get out, and now I do a revolve cut. So I do revolve, and then I change this to cut, and then for the axis I pick this guy, and I okay that, and there we go. That's the head of the hex head. Also, this bottom edge of it needs to have a chamfer, so I go there and pick a chamfer, and here for the value we pick d times 0.1. So this is d times 0.1, and we get the chamfer. There we go. And before adding thread, let's go ahead and apply some material as well. So right click here and go to physical material, and let's say under metal we apply some material, maybe brass. So I drop brass on this and I close it. There we go. That's a beautiful brass hex bolt. And now I need to add the thread. To do that, we go here and pick the command thread, and we want it modeled, not full length also. And the thread is an asymmetric. It is on this face. It's not full length. It's only a portion of it. How much? A common standard is 2 times D. And I want it modeled. If you don't say modeled, you only, as I told you, you're gonna just get a picture, a decal of thread on the part. If you say modeled, you actually gonna see the threads. And this is the tolerance class, and this is the right-handed system, and you okay that, and you should be able to get your perfect thread. Now, what's wrong with this? The only thing wrong with this is in the thread command, it did not allow you to overwrite the size of 10 and this M10 by 1.5 with the parameter D and P. It gives you only a drop-down menu, and you have to pick something out of here. Okay, so this is clearly not fully parametric. If you go now and change D and P to something else, these numbers will not change, and this one also will not change, right? And just to test it here, we go and look at those parameters. So if instead of M10 by 1.5, I want M14 by 2, let's say, okay, and I okay that, you see what happened? The head got bigger, the shaft got bigger too, the length of it didn't. Now let's also modify the length to match, because length is typically 4 times or more than D. So let me also change the length to something like 56 or 60. Okay, so make it longer. Now, what's the problem here? Well, first thing is, if you paid attention here, now this sketch is at 14. That is good, right? So that one gets updated. Then we go to the hex head, which is this one, and it has this sketch, and let's look at the sketch. Sketch is 28, so that is good. The size of the head, this extrusion, let's look at it. That is 10.5, which is 75% of 14. That is also good, right? So you see, lots of the things are good, except for what? When you go to the thread, right? When you go to the thread, still it's 10 by 1.5, and this forces the shaft that was bigger to look smaller. Now look here, if I suppress this for you, this is the bolt. This is the raw bolt. The reason that it looked quite weird, because when you apply the thread of 10 by 1.5, it cuts lots of material out of it. And it trims this diameter of 14 to a diameter of 10. Okay, so you see the thread part is not parametric. In Fusion 360, this is the weak part, and I hope that in the future they fix it. The only getaway around it is, if you don't want to apply this command, is to use the coil command, because coil can give you basically a spiral thing. So let's say here, if I pick it there, and then for this, if I say D, right? And instead of operation of adding body, I cut it, and for profile, I use the triangular external, right? And here for the revolution and height, I use revolution and pitch. Here now for the pitch, I should be able to use P. And for revolution, I should, let's say, I should use enough so that, let's say, 10 revolutions or something. Now maybe that is too far or not. So I don't think it is. It's just going to be, let's see, 5. Just want to make sure that there we go. So 2. So here is the cross section size. And for section size, clearly it has to be less than pitch. So let's say 1.8, and then I make this 10. Okay, so you have to know what is the size of the profile for cutting a what, cutting a specific thread. And the profile of the thread, when you cut it, is not perfectly triangular. The tip of the triangles are kind of cut. There is a chamfer there. And the roots of them, they have fillets. Okay, and the dimensions of them are functions of D. They are not just something simple like this. Okay, but clearly this number has to be less than D, otherwise you will have self-intersection. So you might get something like this, which is, of course, a little bit weird looking, right? And it's more kind of like a power transmission thing, and you see clearly it did not hold all of the angles right and everything. So still, I would say this is one of the shortcomings and weak spots of Fusion, that they did not make all of their commands to accept parameters, and some of them still have drop-down menus. Okay, because in SolidWorks you have drop-down menus, but it also allows you to overwrite the drop-down menu. And this is one of the things that you want to add to the Fusion. I would say for those who are writing the software, this is the place to do it. So anyways, this is a parametric bolt, and you can do other things too. For instance, you can make gears and so on, and hopefully in one of my future videos, I'll show you how to make a gear in Fusion 360. So you can add the parameters in part design, and you can also, when you create the sketches, you can also have parameters in the sketches and use them as well, and they are all under this FX. Okay, so these are model parameters, the functions that you created, and these are the original parameters. So hopefully this simple video was useful to you, and you learned basics of how to create parameters, how to use them in formulas in Fusion 360. Thank you, and I'll see you in the next video.